I'd like to welcome you all to my very first ever YouTube video. We want to start by hitting the ground running. The aim of this YouTube channel is to be, at its core, educational. Now, you don't need qualifications to follow along with what we're going to be doing, but you do need curiosity. And that's why I'm calling this series The Mechanically Curious. Today, I'm going to put my hard hat on and we are going to go and discover how this wash plant operates and functions. Now, it is quite fascinating. So stick around, I'm going to show you exactly how it works. And of course, the sponsor of this series is none other than Holy. They are giving us all the tools we need to get round facilities like this, bring you super interesting episodes about engineering at its finest. As and if the channel grows, we're going to go all over the shop. We've got eyes on engineering facilities all over Europe. And of course, like, share, follow, hit the hype. Let's get some traction rolling. We can go and see some incredible engineering projects. So this wash facility cost £6 million. There is actually £1 million just in the concrete on the floor. This can take pure dirt, essentially, dug out the bottom of that quarry and turn it into usable aggregate within 90 seconds. It is loaded, screened, washed, and then piled up into piles such as this one of all varying different grades. It is quite a piece of engineering. It really is. And soon we're going to hit the button that starts it up. Shortly, we will be joined by Big Steve. Now, Big Steve helped build this thing and he actively maintains it. Why do they call him Big Steve, you ask? Well, he's big and his name's Steve, mainly. But he is the brainchild behind all this, and what he doesn't know about this isn't worth knowing. He's like a walking encyclopedia for this place. Seems we're getting close to the conveyor belts, we better stick our lid on. I'll show you the different grades. If you look at the size of this aggregate compared to its neighbour, it is vastly different. But that'll come out of the same pile, that'll come out the same scoop of dirt that goes in at the start. One of the really interesting things about this wash plant is its ability to recycle. How many hundreds of thousands of gallons of water it would need to clean tons and tons and tons of aggregate on the hour, every hour. This wash plant recycles its own water. It is used again and again and again, which means obviously a lot better for the environment. We'll do a little walk through now while it's switched off, because trust me, it is a lot quieter. This thing makes a hell of a racket. At its highest point, it's about 3 stories tall. As you can see, this huge conveyor belt is your initial belt upwards. Of course, it uses the help of gravity to shake it down those shaker plates, down and onwards. This facility at the end here is where all the muck comes out of the water, and the water is recycled back into the plant. And what comes out of it is referred to as cake. Come and have a look at this. That there is your cake. It's a thick clay-like substance, which is basically the waste. Come on then. That is your dirt that is fed into the initial screener here, and that is where the process starts. I'm going to refrain from telling you any more until we have Big Steve here, because Big Steve is the big brain behind the whole thing. All of this is now starting to whirl into action. Each piece is starting up all around us. As you can see here, these conveyor belts, we're certainly not going to put our fingers anywhere near these things. But our conveyor belts are already operating, because when the dirt hits that end and it starts to work, we don't want these conveyor belts stood still, getting backed up and logged up. Get a little drink down as well, we're waiting for Steve. As a thank you for showing us around, I've got him the Tropical Tiger from Holy. If you've never tried Holy Energy, it is a healthy option to all your fizzy, sugary, horrible drinks. I kicked it 2 years ago, maybe coming up 3 years ago now. I don't touch any sugary drinks, just this stuff. It's packed with minerals, electrolytes. Could not recommend it enough. If you ever want to try it, use the code JackSpanners5 for £5 off your first order, or Jack Spanners for every order after that. Health is wealth. We'll just try and avoid swearing.
That's hard to say.
I know it is.
Yeah, so like that, that's just, you know, no different to someone just digging a hole in the ground and taking out, you know, this mud, this stone, this sand, and then to anybody else it is just a pile of mud. And in particular, they do run an oversize, so everything that goes through there is 100 mil down.
Right.
So everything 100 mil down goes through that and up the belt. 100 mil then goes onto the pre-screen, gets washed. Everything 50 mil down, 46 mil down, continues on through the wash plant. Everything between 46 and 100 mil drops off on this side.
That's the big boy stuff there.
Yeah, and from that, some of it's used for roads, some of it gets crushed. They've got, like I've said to you before, how hard the stone is here. But the bigger stuff, yeah, they have a market for it. Not all plants we put in will run an oversized belt because not everybody will have a market. But you've seen the machinery that Crown have.
That's your heavy stuff. So this is the very start of the whole process. This is where the muck comes in.
You can see the starting material over there. Gets fed in here. When I'm talking to you about the 100 mil down going up, so the mesh on the bottom deck is 100 mil. So everything that makes it through both decks will go up onto the wash plant. So yeah, what's happening is it goes over here, it's screened off and separated. You've got an oversized belt there, so anything 100 mil upwards goes off the end there. They'll take that over to somewhere else on the quarry, they'll crush it down and it'll get put back through. So everything that passes through, off of the main feed belt, got a magnet at the start, taking off any scrap metal in there, any scrap metal.
So any metal that's in there will get picked up by the conveyor belt and flick it off into the
substrate. So yeah, there's your oversize coming off. So it has been washed. And like I say, that can then go on, that'll either be crushed or used for whatever it might be required. Come on. Up the main feed belt, everything like I say, 100 mil down, sand and silt.
I take it puts it this high because you're kind of working with gravity on the way back down.
Yeah, so the screen's inclined, speeds up the process of material running down. You can see the amount of spray bars on there to give it the initial wash.
So that's jetting water in there?
Jetting water in there. So up here as well, we actually flood the material because you want to take as much of the silt, which is smaller than sand, out as soon as possible. You don't want that going through.
See the jets down here. So all these are, that's water feed straight through?
Yeah. So we've got pressure sensor here, pressure of the water.
That's two-tier?
Yeah, so the name of the plant, it being a wash plant, obviously water's the key component. You have to have volume of water constantly to get the dirt off the stone, simple as that. You can have all the machines shaking all you want, if you haven't got the right, enough water, it's not,
absolutely,
nowhere to go.
Do components like this, do they wear a lot? You know, like because that's a lot of movement there.
No, so this will last as long as its lifetime. So the only time you'll ever change that is when the rubber actually perishes just from sunlight.
What about the boots there?
The boots themselves, they'll last years.
Really?
Yeah.
Surprised at that.
Yeah, no, so the spray bars inside have covers over them. Again, so these are obviously in direct line, direct impact with the material falling. So these have polyurethane covers on them. They last. I mean, this plant's been running for 2.5 years now. We've not changed one yet. Effectively two corkscrews. Moves the material up the centre, so it's scrubbing, so it's turning like this, like a corkscrew, and it scoops the material up and it forces it up the middle. We've got spray bars up either side and spray bar up the centre, so again, using gravity, the log wash is going incline, so obviously the water's fed in from the top, comes back, so as the stone's being scrubbed up the middle, the water's running back down and taking the silt and sand away, which comes out the trash screen here.
Oh, all that down there. If you could smell the smell here. If you've ever been on the log flume at Old Towers, it smells like a silty water. It smells like the log flume.
The end game for the stone is to obviously sell it. It's got to be clean as possible. We've obviously got, there's a lot of lignite in there, so it looks like stone, but if you feel it, it's like coal, it's lignite.
Oh, right. That's called lignite.
So that flows. So
it's really light.
Really important for the log wash, again, with the flow of water, anything that's floatable comes out the back with a weir system here, comes over this screen. Like I was saying, all the stone now being fed into the centre there, and as the shafts are rotating, the stone moves up through the centre.
Oh, I understand, yeah. Boy, you wouldn't want to fall in there, would you? Would you, cameraman?
And obviously the higher we get, the cleaner the stone is.
Oh, of course.
Got up to here, it's, you know, it's pristine. So now we've gone from obviously the mud that you've seen over there to what's left now is your clean stone. So
that's all that different grade there.
That's all the different gradings there, everything from sort of 9mm up to probably sort of 42, 44mm.
Oh, really?
So this screen's just dewatering, it's just taking off the last bit of water before it goes on up to be graded.
So all the different sizes there, put together. Let's get this last final one. Nice jets there. That's incredible.
So, like I say, you see it go up from here. We run a secondary magnet as well, just in case anything has managed to get through, to make sure the stone's as contaminant free, clean as possible. We run a second magnet on here as well.
You're doing good.
So during the washing as well, obviously we're washing the stone to make the stone products, but we're also making two sand products here. So all the sand that's in there with all the water makes its way back to the central sump here. In that sump is all the sand, the silt and all the dirty water that's been used. The dirty water from here is then pumped up over to the sand plant where we run a double wash system. So to produce two sands, we have to wash it twice.
Right, okay.
So all of the sand will go through one cyclone, and that'll take out all the coarse sand and the fine sand. Once that's been taken out, it's gone over the dewatering screen where it's jetted to get the fine sand out, which goes into the sump there, which is then pumped up again into the second cyclone to take out
It's a hell of a
fine sand. Yeah.
What goes up here?
Yeah.
It's got to be quite heavy material, the water, the sand mix.
Yeah. So everything in there, you sort of probably 5mm downwards.
Right.
5mm down going up and through that pump. So that takes some battering, that does.
It's like a huge turbo.
This pump's exactly the same as that one, just smaller. And this will take out slightly smaller material. So whereas that's got sort of 5mm down, this is about 2mm down.
Right, okay.
But they'll both go up
That's a lot finer, isn't it?
Obviously within that material over there, you're made up of your stone, your sand, your silt. All the sand's taken out, and this is what you're left with. So we've got a coarse sand this side. So this is what's pumped through initially from the first sump. Spray bars here that jet the fine sand out. The fine sand goes into the sump below, gets pumped back up to the smaller cyclone there. So we end up with a fine sand here.
These are the cyclones they go into. And just look how fine that sand there is coming out compared to this side. Oh, there you go. That distributes it out into its associated piles. Incredible.
Obviously, with knowing that this site was going to have such a large volume of sand, we put radial conveyors in, so obviously the conveyors can rotate round, you can go all the way around, you see the final stop there, so they can have pretty big stockpiles of sand here.
And was there like surveying done beforehand to know what kind of material you're going to be pulling?
Yeah, so they'll do...
And you build the plant bespoke to that survey?
Yeah, so there'll be like geological digs, geological surveys to work out what material is going to be here.
So you're already ahead of the game before you build the plant?
Yeah, you don't want to be spending millions of pounds and not know what you're going to be putting through it.
Absolutely not.
Same as what the pre-screen's doing, shaking the material. The only difference is this is a dry screen. The sole purpose of this is to separate the material, to grade it. So, 2-deck system. So the 40mm will come over the top deck, the 10 and 20 will go through it. 20mm comes off the top of the bottom deck, 10mm goes through it. You've got 10mm running up there, 40mm running up there, 20mm running up there.
Oh, right. Am I right in thinking, the last time we spoke about it, does one of these beds rotate, it shakes backwards?
Yeah, so
to keep the material on longer?
Yeah, we run this screen in reverse, so rather than having forward and throw the material off it, we had to run this in reverse. On the sizing screen, it just gives it a little bit more time for it to separate, so your gradings are as accurate as possible.
Just that minute little bit longer, that helps to grade it better.
Yeah. So obviously that's the end of the process for the solid material. Then it's water.
We've got the recycling plant. So this is the control room. This is like the brain, is it?
Yeah, this is substation for your mains power incoming and distribution, and then everything, the wash plant we've just walked around, everything is controlled from here. Extremely simple and self-explanatory.
Yeah. And it shows you which conveyor belt is piling at any one time.
It's showing you that the conveyors are running. Just again a visual representative to show, make it as simple as possible.
Exactly the plant as well, isn't it?
Yeah.
Like
yeah. Even with the signs up on the building.
Yeah. Brilliant.
So obviously all the solids now have been washed out. We're left with the dirty, silty water. So anything smaller than your sand particles coming off come back along this pipe here and go into the thickener tank. The thickener tank, we run a trash screen on there as well, just to take off any fibres, anything floatable that managed to get across. No, so that's actually another screen, like the dewatering screen on the back there. But yeah, so then the water comes back, the solids settle. To help the solids settle, we introduce a flocculant.
Yeah. This is the scientific bit I like.
So we have an auto-analyzer system, which is taking a sample of the dirty water every 60 to 70 seconds.
Oh, right. That's all happening here in this chamber?
Yeah. So what happens is, that's passing through now, it takes a sample, you see it's starting to separate.
Yeah.
That's actually that's the solids settling to the bottom.
I can see it all moving.
Yeah, so this is currently being timed, and however long it takes for the solids to settle, there's a photo switch across the top there. When that sees a clear signal through, that'll stop the timer.
So when there's no obstruction with the dirt, it sees clear water, which is going to happen shortly.
So that's showing you the flock working,
Yeah.
and that's timing it all the while. And I'll show you later on, but there's set points for the analyzer system, and depending on how long it's taken for those solids to settle, the flocculant here, this is your dosing pump here, that's on an inverter, and that will speed up and slow down automatically to increase or reduce the volume of flock going into the system, which will in turn speed up or slow down what we call the flock time.
And that's now flowing through there.
So that's flowing through there now. You'll hear the valve shut, and then obviously the material will settle and it will start to fall.
And it does this repeatedly the whole time the plane's working?
This is running the whole time. There's dirty water running across.
Yeah.
We have probes up on the top there that tells the computer that there's dirty water running through.
Oh wow.
And all the dirty water that's gone through there drops into this bilge tank. This has just got submersible pump in it, which will then send it back into the thickener tank.
That's like proper science, isn't it? That's incredible.
That's the clever part of it.
That's the clever part.
The dirty water coming back, that's all coming back, drops onto a final screen there that will just take off any of the last fibres, anything floatable, everything else. This is the flock in that tank that's down there, that's actually being dosed in there. We've got a series of baffles in here. Yeah.
So when that's coming out,
the clear liquid coming out,
that's being dosed.
That's the flock being dosed into it. So if you actually got a jug of water now, or an empty jug, scoop that up, you'd physically see the solids like you did in that analyzer.
Oh really?
You'd see it start to separate.
And what happened in that tube happens on a larger scale in this tank.
Exactly that.
And it breaks it down.
Exactly that.
Brilliant.
And then the surface scraper we've got, you can see the surface scraper going round, takes off anything off the top, so it's not going into the clarify tank. What you can't see is that at the bottom of the tank, turning at the same rate as that, is the rate.
Yeah.
As the rate turns, it creates a torque value as the solids settle. A predetermined value which is set up during commissioning, that the torque value that it creates then corresponds to the density of the sludge, because we want a consistent...
How it's been held up by the sludge.
Yeah.
Creates a torque figure.
The thicker the sludge, the more torque it's going to create.
Yeah. Oh, fantastic. Blowing my mind.
So yeah, from here, so you can see the water that's wearing over. It's what we call the clarified water.
We call it wearing over. So
yeah.
It is essentially a weir.
Yeah, that's what it is. And I say with the flock and the solid settling, the clean water sits on the top.
Really? Watch yourself, cameraman. Oh, we don't want to drop the camera down there. So last time I was here, this was a lot higher. I mean, the tide mark was probably up here.
This will just up and down, depending on how they run. The stirrers, you can see, they'll run at set intervals.
Yeah.
So they'll break for 5 minutes, they'll run for 5 minutes. And it's just to stop it settling anymore.
Just agitated up to...
just to stop any more settlement happening. Yeah. That's the part that transfers it over from that tank. We run agitation systems as well. So you see just kicking in now.
Make me jump there. There you go, look. Look. You just had a burst. Start flushing your toilet.
And then I guess this is the final process.
Yeah. Look at the size of that. That's big old bit.
She's a big old beast. When this press went in, it was the biggest press in Europe.
Oh really?
Yeah, first one of this size to ever go in. It was somewhat of a beast. So basically, even though this is called a filter press, it doesn't actually press anything.
Right.
The press in itself, it's done, it closes up and it holds itself shut.
Yeah.
There's a pump downstairs that's pumping the material in. So between each one of these plates, there's a cavity. So it fills from both ends, fills the cavity up with a liquid. Obviously, as that fills up, it creates back pressure. The pump ramps up, so it keeps forcing the material in. The water filters through the cloth, and that water is recycled. So that's gone back to the tank with a rake in it to go back through again. and it'll continue to build, and it'll actually make a dry, solid cake within there. So a liquid's fed in, but the water's filtered out of it to leave a solid, what we call a cake, that then drops out. So from that whole product, everything that was going through the plant over there, the piles of stone, sand, silt, mud, everything, all that drops here, that is your only waste.
Just a complete waste out of all of it.
Yeah.
Everything, all the goodness has been taken, used, and you know, capitalised on. Yeah. That's just the crap.
So you're about 10% of what originally was going to landfill is now going to landfill.
Oh, right.
90% of it is recycled.
Well, there you go.
So yeah, it's
that's quite a figure as well, isn't it?
It's a brilliant process.
That's quite unnerving. And that essentially, so that fills all the way up.
Yeah.
And then
can we see here? So this is now waiting. Again, this is fully automated as well. Yeah. Nobody comes up here and starts this. There's level sensors in all the tanks, and there's limits set, so then we know how much material a single press cycle takes based on a level of the tank. Yeah. So for argument's sake, say obviously that tank's quite big, it might take 10 centimetres for one press cycle. So we will have it that the low limit is say 1.2 metres. Yeah. It won't start a cycle unless it's got 1.4 metres in, so it knows it won't reach the low level before it runs out. So this will not start feeding itself until it reaches that set point. And then what will happen is this will just close up, the pumps will kick in, it'll fill it up, fills it up, so we have a flow meter monitoring the water going back. When that rate gets to a set point, which again is set during commissioning, the press will actually stop. It sends a jet of air through the centre to clear out obviously the liquid mud that will still be in there. Valves all shut, this will open up. Obviously you won't have the gap there, you'll have the gap at that end, that's the hydraulic head, and the cakes will just drop out.
Robot gravity just lets them come out.
It does, but we do have a robot system on there that opens all the plates.
I think I've seen it change.
Yeah.
It does it do like 4 or 5 at a time?
So that is a pack there. Yeah. So it's just 10 plates, and it will shake 10 plates at a time. So anything that doesn't quite drop out on its own, the shaker just gives it a nudge.
It goes.
Gone. And then every
the process, it's really quite something to watch. I probably won't do it today, will it? But no. I'll come back and we'll catch it when it's actually in compressing and releasing, because it's quite something to see.
It is an impressive piece of kit, and I guess for myself who sees it day in day out, I take it for granted. But when I say this is fully automated as well, this will wash itself. So at set intervals, it'll do so many press cycles, and then it'll wash itself. So the robot here can't quite see because the press is open. The spray bar's at the back here. So when it needs to wash itself, it's got a spray bar here. So that will go down, and that'll actually come down between each plate, and it'll wash each plate. Wow. And at the minute, I believe this is set to about 10 cycles. So this press runs 24/7. Obviously, the idea is that the wash plant creates more silt than the press can handle in a day, and the press will run on into the night. So when they come in the morning, the sludge tanks are empty and they're good to run again.
Oh, right, okay.
And at any point,
this will just kick up by itself at 4 in the morning.
Yeah.
Oh wow.
Yeah, it'll just continue to run until the sludge tank's empty. And at any point, if it reaches the set point of a wash, it'll just wash itself. And then if there's sludge in the tank, it'll just carry on and start pressing again.
We'll walk around this thing just to show you the sheer size of it. And you imagine how many cubic meters of cake will go through it, and just extraordinary. And these girders, just to get these girders in and up and bolted on, it's just that is incredible for me.
In terms of engineering, to build something like this, it's huge. At the time, this was the first one. So the beams, I think I explained to you before, the beams come over in 3 sections. You can see where we weld them together. So they're fish plated on the inside, on the bottom, and then it's fully welded around. So these beams were assembled out here on the concrete. And when I say about the engineering, and some people take for granted, it's just it's 3 bits of steel welded together. But when that beam sat on the floor under its own weight, it sat with a 35mm arc.
You have to manufacture the arc into the steel.
Yeah, so we will manufacture the arc with the 3 pieces into the steel to account for when all the weight's on it, those beams sit level.
Wow. It's stuff like that you just would never think of.
No. And it's, you know, like I say, the engineering that's gone into all this equipment is it's mind-blowing. And it's forever it's forever improving, it's forever changing. You know, it's nothing stands still. You know, we're continuously involved with the company that manufactures this for improvements, changes, adaptations. They're always on the end of the phone. You know, they can remotely log in, so they can actually make, you know, changes to the program based on information that we can give them.
Oh, really?
And they can make. Yep.
It's nuts, isn't it? It's just incredible. And here's the big. These are the ramps. This the ramps that. Now look at the size of these ramps. And that's what.
Yeah, so this will close in. This will close into around about 240 bar. It'll close, and then when the pump starts pumping in, and the material creates a back pressure, it goes up to around about 280 to 290 bar.
That's a lot. That's a lot. Beautiful bit of kit.
The plates themselves, the plates are 2 by 2 meters square, and this press has got 220 plates.
220 plates.
220 plates.
And that's about it, isn't it? That's the from start to finish how a wash plant operates. I want to say a big thank you for Crown for letting us come around and look around the plant. Big thanks to Steve from Tyrone Steve basically put this plant in with two of the lads?
Predominantly, yeah, there's 3 of us,
3 lads built this, incredible. From the sponsors, Holy, I just wanted to give you that.
Appreciate that.
Just some bits and bobs. But yeah, thank you very much for showing us around. And that is the end of the video. Thanks for watching.